So now that we've seen how to configure BGP, let's look at OSPF. Remember that OSPF breaks down one autonomous system into different areas. So the first thing to note, we need an area 0 in OSPF. This area is the one that routes between areas. So this area is where you should have an area border router, which has interfaces in more than one area. The routers that aren't the area border router, right, rely on the area border router to route any data into area 1. So these guys need this router to route traffic. And the same case goes the other way. So these routers in area 1 need the area border router to go to area 0. And here we have the area border router, which connects both areas. So one difference to note between OSPF and BGP is that while BGP is used to advertise networks that are in a router's routing table to other networks, OSPF only advertises networks attached to our router interfaces. So it doesn't matter what other networks are on this router's routing table. It's only going to advertise this network and this network. So let's break down the OSPF configuration into 5 easy steps, right? So first, we're going to look at the OSPF configuration. Step 1 is to make sure you have an area 0. Otherwise, OSPF just won't even work. Step 2 is to decide which interfaces you want to include and advertise to the area border router using OSPF. Right? So in this case, we have 3 interfaces. We're including all those interfaces on our router, which just so happens to be, in this case, the area border router itself. Step 3, we got to give the router an OSPF ID number. Here we have it as OSPF 3. As this is the 3rd router we're configuring with OSPF in this example. So now we have to give, in step 4, the router itself an OSPF router ID. Here we're using 3.3.3.3. As this is the 3rd router, we're configuring with OSPF in this example. That's just to make it easy. 3.3.3. It could literally be anything, but let's make it easy so that way if we ever have to troubleshoot something, it's easy. Finally, step 5, we're going to write the networks of each interface we want to advertise. So we're adding the networks using wildcard masks. Notice that this isn't 255.255.255.0. A wildcard mask is basically the reverse of a subnet mask. So if you were to take a subnet mask, in this case, the subnet mask would be 255.255.255.0, and you subtract it by just 255.255.255.255. So like everything being on, you get what's left. And what's left is the wildcard mask. Right? So it's the reverse of a subnet mask. And then this is how we're going to add the networks. And we're also going to add the area in which that network is in. So these 2 networks are in area 0. See, the interfaces are in area 0, while the last one here is in area 1.